This is the chapter 1, the stoichiometry and calculation with chemical formula and equation. Who, what, when, and why the mole concept. Who? The German chemist named Wilhelm Ostwald created this term. What? A term used to describe the amount of substance Avogadro's number 6.022 times 10 raised 23 particles atom or molecule or of substance. When? This term was first used around 1896. Why? The purpose of this term is so scientists can know exactly how many atoms or molecules are reacting together and what product they form. Mole denote a collection of a large fixed number of atoms or molecules. Abbreviation for the unit is mole. The amount of substance containing the same number of atoms as 12 grams of pure carbon. Avogadro's number equals 6.022 times raised 23 atoms or molecules mole of substance. For more information, you can watch this video about the chemical balance. The anatomy of chemical equation. We have to make the balance equation, which is the 4 gas of methane plus 2 grams of oxygen equals carbon dioxide 2 grams plus 2 grams of water. That is the chemical balance equation. Number 2, anatomy of chemical equation. 4 grams of methane plus 2 grams of oxygen equals carbon dioxide 2 grams plus 2 grams of water. Reactant appear on the left side of the equation. Number 3, anatomy of chemical equation. The 4 grams of methane plus 2 grams of oxygen equals carbon dioxide 2 grams plus 2 grams of water. Product appear on the right side of the equation. Number 4, anatomy of chemical equation. It is same with the previous, but the state that the reactants and product are written in parentheses the right of each compound. The number 7, anatomy of chemical equation. Coefficient are insert to the balance of the equation. Subscript and coefficient give different information. The chemical symbol H2O, 2H2O, and H202, meaning 1 molecule of water, the 2H2O, 2 molecule of water, H202, 1 molecule of hydrogen peroxide. Composition, the 2 H atoms and 1 O atom, 4 H atom and 2 atoms, 2 H atoms and 2 O atoms. Subscribes tell the number of atoms each element in the molecule. Subscript and coefficient give different information. The chemical symbol H2O, 1 molecule of water, 2H2O, 2 molecules of water, H2O2, 1 molecule of hydrogen and peroxide. It is same in the previous, but the subscript tell the number of atoms or each element in a molecule. Coefficient tell the number of molecule compound.
Now let's proceed to the reaction types. For more information, watch this video. Combination reactions. 2 or more substances react to form one product. Watch these examples. 2 magnesium plus oxygen 2 grams equals to magnesium oxygen. Decomposition reactions. One substance break down into 2 or more substances. Watch these examples. Combustion reactions. Rapid reaction that have oxygen as a reactant sometimes produce a flame. Most often involve hydrocarbons reacting with oxygen in the air to produce carbon dioxide and water. Watch these examples. Now let's proceed to formula weights. The amount unit defined since 1961 as 1 1/2 mass of the 12 carbon isotope, 12 carbon equals 12 amount of unit. Formula weight or FW. Sum of the atomic weight for the atoms in a chemical formula. So, the formula weight of calcium chloride. These are generally reported for ionic compounds. Molecular weight or MW. Sum of the atomic weights of the atoms in a molecule. For the molecule 18, CH, the molecular weight would be carbon to 12.0 amount of unit plus hydrogen 6 1.0 amount of unit equals to 30.0 amount of unit. Percent composition. One can find the percentage of the mass of a compound that comes from each of elements in the compound by using this equation. Percent element equals number of atoms atomic weight over FW of the compound equals 100. Percent composition. So the percentage of carbon and hydrogen in 18, carbon 2 and hydrogen 6 molecular mass equals 30 is percent carbon equals to 12.0 amount of unit over 30.0 amount of unit equals 24.0 amount of unit over 30.0 amount of unit times 100 equals to 80.0%. Percent hydrogen equals 61.01 amount of unit over 30.0 amount of unit equals 6.06 amount of unit over 30.0 amount of unit times 100 equals to 20.0%. Now let's proceed to the moles. Atomic mass unit and the mole. Amount unit definition 12 carbon equals 12 amount of unit. The atomic mass unit is defined this way. 1 amount of unit equals 1.6605 times 10 raised to negative 24 grams. How many 12 carbon atoms weight in 12 grams? 6.02 times 10 raised to 23. 12 carbon weight 12 grams. Avogadro's number, the mole. Number atoms equals 1 atom, 12 amount of unit, 1 amount of unit, 1.66 times 10 raised to 24 grams times 12 grams equals 6.02 times 10 raised to 23. 12 carbon weight 12 grams. Therefore, any single molecule laboratory size sample. Avogadro's number of molecules 6.02 times 10 to raise 23. 1 molecule H2O 18.0 amount of unit equals 1 molecule H2O 18.0 grams. 6.0 times 10 raised to 23. 1 mole of 12 carbon has a mass of 12 grams. The mole. The mole is just a number of things. 1 dozen equals to 12 things. 1 pair equals to 2 things. 1 mole equals to 6.022 141 times 10 raised to 23 things. Molar mass, the trick. By definition, this is the mass of 1 mole of a substance. The molar mass of an element is the mass number for the element that we find on the periodic table. The formula weight in Amos will be the same number as the molar mass in G mole. Next is using moles. Grams, use molar mass, moles, to use Avogadro's number, and formula units. Moles provides a bridge from the molecular scale to the real-world scale. The number of moles correspond to the number of molecules. 1 mole of any substance has the same number of molecules. Mole relationships. 1 mole of atom, ions, or molecules contains Avogadro's number of those particles. 1 mole or molecules or formula units contains Avogadro's number times the number of atoms or ions of each element in a compound.
I know gold is not enough.